Welcome, Don Boxley from the H2I company protecting, amongst other things, the Internet of Things. And yeah, that's basically what we're here to talk about. So welcome, Don. Nice having
Yeah.
you.
Yes. Thank you.
Um,
Yeah. Glad to be here.
could you give a short intro to what the H2I does in general? And
Sure. Yeah. In general. Yeah. Yeah. So DH2I, funny name. We started our company, my co-founder and I, in 2010, and our initial business was focused around high availability. We introduced a product in 2012 that made it easy for customers to encapsulate workloads and move them quickly from one server to another server. And that's been very successful for us. But one of the things we found that our customers wanted to be able to eventually move workloads across networks, right? And if they owned, the whole perimeter, if you will, security perimeter, that was relatively easy. But when our customers were confronted with moving a workload from on-premise to the cloud, that was a challenge, right? Because they didn't own that part of the network, and so that inspired us to solve that problem for them, and we came up with DX Odyssey, the first product that we focused on the software-defined perimeter. And with DX Odyssey, it gave our customers the ability to move workloads across networks, and so that's how we kind of got going. And then we've had some potential customers and partners come to us and say, hey, we really like this. Could you make it work in an IoT environment? So I guess the short of is, we started a company focused on high availability, and we've added network security to it. So those are the things that we concentrate on as a company.
okay, sounds great. And how does the software-defined parameter technology work, really from a technological point of view?
Yeah, yeah. So the idea is trying to find a better way initially for customers to support the remote users, right? Traditionally, that has been done using a VPN. And a VPN, we liken that to a kind of, if you will, the drawbridge and moat, visualization. Imagine you've got a castle, you've got a moat, and you've got a drawbridge. And so when a customer creates a VPN, they essentially, for their remote users, that gives them, the ability to get into the castle. So we lower the drawbridge, and they can come into the castle. The issue that our customers and all customers with VPNs are confronted with is that once you've given somebody access to the castle, you're not really sure where they're going, right? It may be initially, you just wanted them to go into the kitchen, but because of the nature of VPNs and the fact that they're actually on your network, they can eventually roam around the entire castle. And that's what you see happen when you see these breaches, right? Somebody has stolen somebody's credentials that has allowed them to, get access to the castle, and they can kind of start roaming around and creating all kinds of trouble. With SDP, the goal is getting them into the castle, but locking them down into just specific room within the castle. So the customers never, if you will, the users never actually on your network. They just have a tunnel to a specific service. In our analogy, I have a tunnel, secure tunnel to, the kitchen. And so that's the only place they can roam around. In fact, if it's done properly, they'd only have access to a specific item within the kitchen, say the oven. And so the only thing they're authorized to do is to bake. They can't do anything else, right? So with VPNs, obviously, as I said, they can roam. With SDP, you can tie them down to specific service. So with our customers, they use us to provide tunnels to specific services. The actual user never's on your network, and even if their credentials are compromised, whoever's got their credentials only has access to what that specific tunnel is tied to, specific service. So yeah, could they screw up your oven? Absolutely, if they have permissions to do that. But that's the extent of it. They can never kind of do a stealth mode of, okay, let's go see what else is going on in this kitchen or the larger castle. Does that make sense?
Absolutely. I think it's a really good analogy. You know, I'm a huge fan of analogies actually. So yeah, it
Yeah.
absolutely makes sense.
Yeah.
Now let's
Yeah.
maybe step back a little bit
Yeah.
to the Internet of Things. I mean, we
Yes.
all know it's a upcoming topic, to put it mildly. It'll
Yes.
probably change the way we interact with each other, the way technology works for decades to come.
For sure.
But we also know, and we've also seen a lot of security issues,
Yeah.
starting with the
Yeah.
MIUI botnet back in, when was it, 2018?
Yeah.
And I'm sure we haven't seen the last of that. So
Mm-mm.
what are the general security issues when it comes to the IoT?
Yeah, yeah, and that's a good question, because as we thought about, the first one that the customers. I mean, obviously, there's we. Hmm. So one at the top of the list for for our customers as we've interacted with them is just how do I cross networks? I'm moving data across, again, networks I don't control. How do I make sure that that data that I'm moving back and forth is secure? So that's one thing. The other thing that they find that's really challenging is, okay, how do I securely provide access to that Internet of Thing, right? Because as I kind of outlined earlier, they know that using a VPN is not the proper way to do that, because they don't want somebody to have complete access to, potentially access to, the entire device. The other security issue that our customers are confronted with is, okay, how do I secure the data that's actually in the device? Again, the analogy would be, not actually analogy. I've got transformers, right? So one of customers that we've talked to in a utilities business, they've got transformers that they want to access 24/7. They're collecting lots of information about those transformers, doing analyses right there. They want to make sure that that data is secure. They don't want some bad actor having access to what's going on with their transformers, right? The data that's there. For others that may be more competitive, right? Mining companies. So, they've got, these devices that are running in mines thousands of feet below, the surface of the earth. They're analyzing ore for certain, characteristics, like, okay, this is a great place to drill, but that place isn't. They don't want their potential competitors accessing, right, those devices that would give them a heads up on what they're up to. That, oh man, this is a great place, we should lock up this particular place, this mine before, or this area before, before they do. So you've got those issues. The other, challenge that from a security standpoint that our customers are confronted with, kind of a big one, is, okay, how do I manage access, or how do I define specific policies that govern how these devices are accessed, who accesses them, and when that happens, right? So those are some of the high level ones that that our customers have come back to us and said, these are issues, can you help us solve those problems? Because as you said, initially, you just had a few devices, but it's quickly, moving from a few to millions, maybe billions of devices, right? Scattered around the world doing all kinds of different things. So, and they all share the same characteristics. I've got you probably yourself, I got a new refrigerator. It's very smart. I can talk to it, with my phone. I can tell it,
Yeah.
how much ice to make and not to make, right? Somebody hacking that, right? Just for kids, right? Some kid, just for fun. I'm just gonna have this thing like go crazy, right? And it's like making ice 24/7. It's all over everywhere, right? So just little stupid things like that, right? For how do I lock those things down so that only I or LG can access my refrigerator? So anyway, those are some of the things that we see are security issues for customers deploying IoT devices.
Yeah, yeah, I know what you mean. We had a case here in Germany for a minister of state, and she had apparently, or she said that her smart TV has been hacked. Turned out it was just a misconfiguration by someone else in her household. So it wasn't all that bad. But I know
Okay,
what you
good.
mean.
Yeah. Yeah.
IoT is a tricky thing.
Hmm.
Now, when I saw what you were announcing today, the new product, You mentioned the edge computing factor of that,
Yes.
and I believe
Yeah.
one of the advantages, of course, using edge technology over, well, say a transfer of data from IoT devices directly to the data center, to the cloud, is obviously that, you know, a lot of these IoT devices, they don't even have the possibility to talk to the cloud. You know, they need a short range transmission like Bluetooth or Zigbee or what have you.
Exactly.
But those edge devices are usually small computers, small servers. I can imagine if you're talking about consumer products, Raspberry Pi is something that comes to mind.
Exactly.
Isn't the Raspberry Pi powerful enough to host a, let's call it, regular security solution with a VPN and everything?
Um, yeah, I suppose, you know, if somebody really wanted to do it, I would hesitant. That's not the way I would do it, right? Because again, as you say, Raspberry Pis, I mean, they are computers, and and for what they do, they're very powerful. But if you give somebody a VPN access to your Raspberry Pi IoT-based device, they could hack it and gain full control of it. So I think that's what we, you know, what we've done with taking DX Odyssey and optimizing for IoT, right? So if and as you say, we actually used a Raspberry Pi 3 as our design center, right? Basically, we said, okay, we need to be able to take our SDP software that we're used to running on the biggest servers in the world and shrink it so it can run on a Raspberry Pi 3, and that's what we've done. So. Preserving, you know, the value of a Raspberry Pi 3, but making it almost unhackable when it's used as an edge device, if you will. Yeah.
But if you have the UX software you have as a central point within the Raspberry Pi, if someone gets into that software rather than getting onto the operating system level, what's the difference?
Okay. Yeah, and that's a really great question. So imagine our software, again, going back to that analogy that I described earlier around the castle. It essentially, when we run, let me back up. So DX Odyssey for IoT is a container, right? So it runs under the Ubuntu's got a version of their Linux operating system specifically for Raspberry Pi. So, you know, you load the Ubuntu, you load our software on, and then you know, you're able to talk to, you know, another gateway, DX Odyssey gateway anywhere in the world, assuming that Raspberry Pi can somehow get access to the network. We don't care if it's a hard connection, if it's, you know, LTE, you know, 5G, doesn't matter. As long as it can get onto the network, we can establish a secure tunnel between it and its hub, wherever that hub is. Once that's done, there's no way for you as a bad actor to get access to it, because there's two things that happen. One, the connection between the Raspberry Pi and the hub is completely invisible to you, right? We use one of our innovations is we use UDP
Okay.
ports that are randomly generated between the device and the hub. So if you had like a supercomputer and you were scanning, you know, 24/7 and running, you know, you might be able to find it, right? Find the specific, you know, ports that we're using to form this link between the device and the hub. But even if you found, you know, the port, all you would see is there's some activity. There's data being transmitted between out of this specific port on the Raspberry Pi. You wouldn't know what it was because it's completely encrypted, right? So it would be a fruitless activity, right? And I think that's the value of using SDP and specifically using DX Odyssey for IoT in this setting. It makes the IoT device, edge device, basically unhackable. The only way that you'll be able to hack an IoT device is if you were able to get the credentials of the specific programmer who actually has root access to that device, right? And in that scenario, I can't help you, right? But assuming you're following, the customer's following good IT practices, they're never going to be able to get access to the device via DX for IoT. Just never going to happen, right?
But let's say they do get access to the edge device itself. Would they have access to your software as well?
In that case, yeah, if they had root access, they would have access to it. They would be able to then potentially understand, what's going on the other side. They know that there'd be a tunnel, and they would know that it's talking to something somewhere else. But again, short of that, they might be able to potentially, if they, worst case scenario, if somebody's have to be, they'd be really sophisticated. They'd have to basically reroute that tunnel to another DX Odyssey hub that they controlled. So in that scenario, yes, right? Yeah, they could reach, just right. Full disclosure, they could reroute traffic from the customer's tunnel to their tunnel. But in that scenario, right? Yeah, you'd have to. But again, it's all predicated on the bad actor getting root access to the IoT Edge device.
Yeah, I see what you mean. I think that's a general. I wouldn't call it problem with the IT security industry, but I believe that all these potential attacks, they have to get more sophisticated. And then, of course, there are more sophisticated solutions to protect against that. But I have a feeling we're a little bit where it might become too over-engineered, everything. And then if you look at the actual attack surface or attack approaches that hackers usually take these days, is very often social engineering, because that's still the simplest thing to do, right?
Yeah. I think so. So could it do it? But I think the probability, if it's well managed, and it's not at that point it becomes a policy issue, right? People management issue, right? Yeah. If you're leaving passwords like using your stupid passwords, and that's always, and that's right. Every when you get these reports, we all do, right? What's the most common security problem for a company? Number one at the list is just bad passwords, right? Yeah. People just use dumb passwords, right? So you gotta do things that are just a little bit more difficult than
Yeah. Maybe one thing, because going back to the Internet of Things here, yes. I think the bigger part of the industry has understood the security challenge that come with Internet of Things. However, there's already some devices out there. How can we protect those? Obviously, hoping that in the future we will have more secure devices. And is that something, or is your solution something which companies can sort of retrofit so they can put on existing networks?
Yeah, that's a great question. Yeah, and that's one of the things that we definitely we think customers will be able to do. The way we designed it, right? Assuming that the customer has used, say they've got a Linux operating system, because we support all flavors of the Linux. If they're using Windows, a version of Windows, they'll be able to use our stuff. They can load it onto it today, and they can, and obviously they buy DX Odyssey for their hub and load that on their hub system, and they can start forming tunnels today. So they could retrofit their devices today. Now, I can't speak to them in terms of how they do that, and that's one of the challenges, right? That just, it's not so much a security, but it's just a management issue. I've got all these, let's go back to like my refrigerator. I got all these refrigerators out there. All these customers have bought them, and now I want to update their security. How do I do that, right? So if I haven't made provision that allows me to basically say, okay, we're going to do a quote unquote firmware update. Don't do anything to your phone, your refrigerator for the next half hour. Then, I don't know how you do that. So that's one of the things that I think the challenge is for companies deploying these devices. They have to make provision for being able to update if you will, the firmware software of the device so that they can keep it current. Because, you know, a lot of those devices that were, as you say, were shipped, they just didn't have access to this kind of technology. It didn't exist, right? It just didn't exist. Now it does. So, you know, I'm not saying they do it right this second, but as they're thinking about the next generation, right, when they kind of roll their quote unquote software, not that would be an opportunity to kind of integrate us into their stack to make their devices more secure. But that again assumes that they have made a provision for being able to do that.
Okay. Yeah. Now, looking a little bit into the future, a combined question from two questions. So one,
Yeah, sure.
it might be a little philosophical, but what do you expect for the cybersecurity industry in the next couple or 5 years, and particularly what are your plans as a company for the next 2 or 5 years?
Yeah. So I think that, you know, there's all, and I think you see it right in the immigration, right? I mean, I traveled to Europe. I haven't obviously traveled to Europe, you know, recently. I actually had a planned trip to Sweden for a wedding, but that was canceled for, you know, for obvious reasons. But, you know, last year, right, you know, there's a lot of more biometrics that are being, you know, being deployed, you know, just right, immigration in and out, right? Looking at your passport, you know, stuff like that. I think that's going to be becoming more prevalent, right? That in order to solve this problem that we described earlier, how do I keep people from actually hacking my credentials? I think they're going to be more biometric driven, right? Making it much more difficult. You see now, right? You've got two forms of lots of multi-factor, right? You know, they're asking two questions. They're going to send a text to you. You got to enter a code, and then you can, you know, you can get access. I think it's going to get more sophisticated, and it's going to be more generated around, you know, specifics of biometrics. You know, I think Apple's been leading the way there. Maybe that's too strong a word, but obviously, you know, with their iPhones, you know, they can look at your face, facial recognition. I think all that's going to get much more sophisticated, right? So I think that's an obvious way for things to get locked down over the next 5 years. For us as a company, you know, we're going to ride on those trends, right? You know, again, our whole the place where we think that we're going to be continuing to innovate is making those tunnels between two endpoints more and more secure, more invisible, right? So we don't really care what the transport medium is that the customer's using. Like, as I said, could be Wi-Fi, could be 5G, could be a landline, you know, whatever makes sense for their application, we'll just ride on top of it. But the issue that they're concerned about is the tunnel super secure? Like, how can I make sure that that scenario that I described to you, somebody hacking my device, getting root access, and rediverting, right, that tunnel to some other point that I don't have anything to know about, and so, or setting up two tunnels, right? I'm getting the data, but my competitor's also getting the data, right? So how do I, you know? So we'll be focusing on making that potential scenario very, very, very difficult.
Okay. Well, thanks, Don Boxley from the H2I. That was really interesting and very interesting. Well, yeah. Can you call it a concept, a software-defined parameters? Is that?
I think it's definitely it's definitely a philosophy around how you would, you know, build a zero trust environment. And, you know, we think that the software-defined perimeter is a key component to generating and creating a zero trust network for your organization.
All right. Well, thanks. And yeah, I'm hoping to hear and see more from you in the future.
Yeah. Well, we appreciate the time.
Absolutely.
Yeah.
Thanks.
Okay.